Okay, so here is 3.2 logical operators. And it said 3.3. I've been adjusting this from last trimester. I've moved it around because I believe that logical operators should come before a switch statement. So let's talk about what logical operators are. And it can be used to identify logical operators in Java and write Boolean expressions that combine multiple conditions using logical operators. And we kind of saw that in the last section when we did is the temperature greater than 60 and less than 80. So we're going to really dive into that and really kind of talk about what logical operators are. So think about these questions. Do they make sense? Can you be older and younger than your siblings? Is that going to throw a true or false at you? Can you work at Burger King and McDonald's? Can you sleep or eat at the same time? That's a tricky one, probably a debatable one. If it is raining and I have an umbrella, will I stay dry? I will go out if it is Saturday and I have no homework. A number is even and greater than 10. So you can start to see how our progressions, though they might have been a little bit out there, eventually start to hone into the idea of, is a number even and greater than 10? We can start to really look at that through a computer programming eye. Okay? So let's kind of go on. How does it work in code? The and is what we call ampersands. These are the ampersand symbol, and it's an and. So if you do a double ampersand, that is what is used for an and. And it's the Shift 7 key, by the way. We should add that. Let's do that. Shift plus 7 equals ampersand. Okay. This one is going to be shift plus backslash equals that, an or. And then a not is a shift plus 1. Okay. All right, there we go. So we have and, we have an or, and then we have a not. And when we saw that exclamation point, that's what it meant. It meant not. So when you see these, you will have the and, an or a not symbol in your code. So let's take a look at that. If we initialize our Boolean variables, so we're going to say that Boolean A is true and Boolean B is false. And then we're going to test out the and. So can something be true and false? What would our result be here? False. It can't be true and false. Can you be older and younger than your sibling? It can't be, it's got to be one or the other. So if you put an and there, that doesn't work. And the logical operator is if it's true and it's true, then the outcome is true. And then you go from there. change it up. If it's false and it's false, is there any way to make it true? No. So let's look at that. So if it's false and it's false, then your resultant is going to be false because it can't be true. Okay, so let's comment that one back out. And let's try the next one. So now we've got an or statement. So can it be if it's true or it's false, what's going to be my resultant? And remember, if one or the other is true, it will make the statement true. Can you be older than your brother or younger? So can you be older or younger than your sibling? Yeah, you're going to be one or the other. So this should put out a true statement. Okay, a not statement. So if we are not true, if we are not in A, if we are not true, then that should make us a false statement. Let's see if we are a false statement. There you go, we're false. I don't know why these are all lined up. Kittywampus is what they would call it. Not B. So if we are not false, what is this going to result at? So think about that. If we are not false, what are we? And hopefully your brain is telling you true. Yeah. Good. And that there, and then that gets closed there, and that gets closed there. Okay, that's right. I don't know what the alignment was, but it wasn't. Feel free to change the num values. So we have an integer, the number of 25. Okay, so before we get there, let's continue on. So we did this. Practice on your own. If you get stuck, ask the neighbor. All right, so here is problem number one, number range checker. Write a Java program that asks the user to enter a number. Okay? Use the logical operators to check if the number is between 10 and 50. And then if the number is less than 10 or greater than 50. And then if the number is not equal to 25. So let's start there. Write a Java program that asks the user to enter a number. So the first thing I want to do, ask user to enter a number. So what do I need? I need a system.out.println. Please enter a number. Oh. How are they going to enter it? With a scanner. New scanner. System.in. Okay, so let's move this over here a little bit. Okay, so we need, when you are using Java in anything other than SoloLearn, it will prompt you as you go. And so you need these types of questions in there to prompt you as you go. So what I need is, I needed to enter a number. Now, it's going to throw some errors at me because I'm trying to use a scanner. Scanner isn't working properly because why? Ask yourself that question. And it's because a scanner is a utility. It's a Java utility. So we need to import it. Now that's going to prompt us to please enter a number. Okay. Now, did it actually ask us to enter a number? No, it didn't, because we haven't said anything. So what we want, so ask the user to enter a number. Initialize your variables. And I am going to call this integer a number. And it's going to be my scanner scanner's next integer. I don't. Okay. So to get that number to be the next thing, you need a int to tell it what kind of variable it is. And mind you, you can change it to a double. But if you do that, you definitely need to change this to a double so that it registers properly, so that I can put 1.6 in and still no error message. It's not going to input our number. So what we want to do is make this a print statement. And then after we actually get what that number is, do a system.out.println, and then we're going to put number here. So what we did is we have it print out, please enter a number. Then it's going to bring up our scanner. We're going to enter something into the scanner. Hopefully it's a double. And then the scanner dot next double is whatever we get. So if we can put 12.5 in, okay? And there we go, 12.5. And because we used an ln, our next statement is going to be in a new line. I'm going to put a space here because I think it's a little tight. We'll still put that 12.5 in, but you can see it'll push it over just a little bit to give us a little space. All right, now, excuse me. What happens if we put a letter in? Exception, doesn't work, okay? That's because it doesn't register as the next double. It's giving us a letter. What we can do, and what we will do in the future, is write an if statement, and if it's not a double, we can send it back to do it again and again and again until we do get that. And that's where what we call a loop happens, where we're going to keep you doing this until you can do it right for us. Okay, so now we've gotten our number. So we've gotten 56.3. Whatever you want to put in here will work as long as it's a number. Okay, if it's not a number, we're in trouble. But once again, write a Java program that asks the user to enter a number. We're hoping that the user is smart enough to put a number in. All right, that's why we say please enter a number. We're telling the user what kind of input we want. We're hoping they can do it. You can write code in order to do that, but we're not going to worry about that today because that's not what our lesson's about. Our lesson is about making our logical operators in our statements. So our first one, if the number is between 10 and 50 inclusive, okay? So now we want to see our number is equal to, is our number greater than 10 and our number is less than 50. Okay? All right. So our number is greater than 10 and our number is less than 50. Once again, though, inclusive. What does inclusive mean? It means we want it to equal 10 and we want it to be able to equal 50. So if you're going to make it inclusive, you want your less than, greater than symbol, whatever it is, then you want your equal symbol as well to show inclusion. Because if it is 10, I still want this to come out. If it is 50, I still want it to come out true. So let's set this whole thing Boolean is true. And we'll say is true 1. So is true 1 actually true? 12.0. We have 12.0. All right. No error messages. Gave us 12.0, but it also didn't tell us true or false. Or did it? Did it tell us if it's true or false? It told the program whether it's true or false. It definitely told our program, but did it tell the screen? Well, that's when we need a system.out.print is true 1. Now it will print it on the screen to let us know if 15.6 is greater than 10 and less than 50. And we can see, please enter your number 15.6. That is true. But what is true? Well, that's where our number is greater than 10 and less than 50 inclusively. End quotes plus. So you can give it a little prompt to explain what our answer is. Actually, let's do that. Let's test out a really large number. So is our number is greater than 10 and less than 50 inclusively. That is false. Okay? So whatever you want is how you want it to prompt. So that used our AND logical operator. Okay? What if it was an OR? Well, if it's an OR, we can literally copy this. We can paste it and change the ANDs to an OR symbol. So is the number greater than or equal to 10 or is the number less than or equal to 50? And if we run it, we do 15.9. Ooh, error. Oh, the reason it is because I use the same variable for two different things. So that's how. Let's do 156. So please enter our number, 156. Our number is greater than 10 and less than 50 inclusively. That is false. And 156 is not greater than and less than. So let's copy that. Let's copy, and we're going to paste. Now, be careful. Right off the get, we want to change that to is true too, because we made it a second one. And then we want to put a big fat OR there. And I'm going to put a big fat AND here. Because that's really what today is all about, are these logical operators. And we have an AND and we have an OR. So let's run that. So a really big number. Well, let's do some print lns. Print ln. Okay. Let's do a really big number. There we go. So please enter our number. Our number is 561. Our number is greater than 10 and less than 50 inclusively. That's false. Our number is greater than 10 or less than 50 inclusively. That is true. Because it's greater than 10, it might not be less than 50, but it's greater than 10. Now, let's run it one more time and just show that if I put 24, which is greater than 10 and less than 50, this is true. This is true. Okay, that is true. And then this is also true, because if it's greater than 10 and that's true, then the whole thing's true no matter what. Or if it was less than 50 came first, and then that's true, the whole thing's going to be true. All right, last thing we want to test out. And we're going to copy and paste it one more time so that we can adjust. And we're going to call it isTrue3. And we'll call this isTrue3. But what we're going to test this time is our number is not 25. Okay, so our number is not 25. So when we do that, we have to look at our number and make it, oops, sorry. So look at our number and make it not equal to 25. And then we can get rid of all the other logical operators. So we're just looking at the not equal to. And if we set 36, 36 is not equal to, is true 3. 3 disappeared. Let's do 31. So let's take a look. So our number is greater than 10 and less than 50. That's true. Our number is greater than 10 or less than 50. That's also true. Our number is not 25. That is also true. So let's test out the one we want to see. Type in 25. And hopefully you should think about what your result would be. And it's false. Our number is not 25. That's false, which means it is 25. So that's how the not logical operator works. All right, so I hope you found some fun in this and the logical operators. I think it's a pretty cool, I don't know, I really like it. I think it's a cool idea, and putting those logical ands, ors, nots, those are fun. And starting to get us to really almost get to feeling like, man, I could code something that could actually do something. A lot of times we've just been doing system.outs and those types of things where we're starting to build now where we can actually start to create some stuff and some pretty cool stuff. So hope you enjoyed this. We'll move on to our switch statements, but this is 3.2, logical operators.